So let's see how fast we can go through these. Question 1 says that y is equal to cosine of 2x, and what is dy dx?
Negative 2 sides.
Now, good news. I took this test yesterday, because I didn't want to just put the answers down. I wanted to know, right? And I got them all right. It's the first time I've ever gotten. I make at least one mistake, right? I got them all right, and I'm really excited about that. Well, yeah, but the thing is, I've also been doing it for what, like 7 years? Okay, so I have a little bit of an advantage over you guys. And I teach math all day long, so yeah. So I have a little bit of an advantage. Okay, all it's asking for is the derivative of this. And what rule do we want to use here? Chain rule. Derivative of the inside is 2. Derivative of the outside is negative sine inside of changed. There we go. So, all right. So that's option. What do we get? Option A. There we go. All right.
All right. That's a good start.
That is a good start. Yeah. And by the way, somebody made one time. I can't find it, but they made like a list of like 10 first questions on all the AP exams that AP Calc exams they could find, to show that usually the first question on the AP exam is an easy one. Okay, so just go in assuming that the first question is easy. It's okay. It's okay. Because didn't we just say yesterday sometimes we overcomplicate questions?
I feel like I do that.
Yeah. And some of these are actually way easier than you think. All right, question 2. I'm going to show you something interesting about question 2, and then we're going to do it the official way. We're going to do it the unofficial way that because I'm sort of I'm a grappler. I'm a dirty fighter. Okay? I don't really fight, but I mean, if I were a fighter, I would be a dirty fighter. I'm the kind of person that just gets at accomplishing the goal. All right, here's the deal. This says antiderivative. The whole thing is polynomial, right? Yeah. So here's what I'm thinking. I'm thinking that the answer to this should be 1 power higher than whatever power this is. Does that make sense?
Yeah.
Well, this is the 3rd power to the 10th power. So this is a 30th power polynomial. And if you multiply by x squared, now it becomes a 32nd power polynomial. So the answer is going to have to be a 33rd power polynomial. But look at the first one. The first one is like a 43rd power polynomial. The second one is a 33rd power polynomial, so it could be B. C is a 35th power polynomial, so it can't be C. D is a 33rd power polynomial, and E is a 36th power polynomial. So we know it can't be A, C, or E. It has to be B or D. Isn't that cool how we knocked it down to a 50-50? Just like in, what do you call it? Just like in, what's that show? Who Wants to Be a Millionaire or whatever? And you do the 50-50.
Oh, yeah.
They knock off the answers so that you're only picking between 2. Okay, so now if you're down to, you have to guess, you're only guessing between 2. All right, so it's either B or D. Which you could take those answers and do the derivatives of those answers. Okay? You know it's not B?
I know it's
because you picked B and so I guess that makes it D. All right, let's do it the official way. We need an antiderivative. What technique are we probably going to have to use here? Let's look at this. If we were doing a derivative, what would we have to use? All right, let me call your attention to the fact that inside is the 3rd power and outside is the 2nd power. This is U substitution. And anytime your power on the outside is at the derivative level of whatever the power of the inside is, like if we have a sine on the inside and a cosine on the outside, U substitution. Okay, there's only 2 options for integration. You are either doing a regular integral or U substitution integral. There's no other options. We didn't learn any of the other integration techniques. So those are the only 2 options. So what would U be in this case? X to the 3rd minus 1. What's the next step?
du
dx equals 3x squared. And then what? Move the dx to the other side. So we have du equals 3x squared dx, right? And then solve for dx, right? So how do I solve for dx?
You multiply by 1 over 3.
1 over 3x squared, right? 1 over 3x squared. And now dx is all by itself. And now we can come up here and start replacing things. We're going to replace this, and we're going to replace this. We're going to put u here, and we're going to put du here with the 1 over 3x squared, right? Am I doing this too fast? I'll slow down. I'm going to slow down.
Yeah,
Sorry.
are we moving the exponential now?
Well, watch what's going to happen. I'm going to substitute the things first,
Okay.
and then you'll see that things are going to start getting canceled. So if I replace this with a u, I'll now have the indefinite integral of x squared, and then I'm going to put a u here, so I'll have times u to the 10th power, because the 10th power is still there. And then instead of dx, I'll have 1 over 3x squared du. Now look at this. See this x squared here? I'll stop for a second. And then this at 1 over x squared here, they're going to cancel. So now that's gone, and all I now have, it's much cleaner now. I have a 1/3, which I can put outside, and then I have a u to the 10th power and a du. Now, find the antiderivative of that. This is now much easier. Now we're down to where we're just doing a basic power rule.
So now it's over 11.
Mm-hmm. Yeah, okay, remember, we power up, we add
11.
1, then take our new power, 11, and multiply by the reciprocal of that, 1 over 11. Right?
Times 11 is 30.
Yeah, and we have a 1/3 on the outside, so we now have a 1/3, we have a 1 over 11, we have a u to the 11 power, and then we would have a plus c also. And so now this is 1 over 33. U to the 11th is x cubed plus 1 to the 11th. And now we're at the point where we can look at all the answers. And which one matches now? D. Does that help a little bit? Do you guys remember when we learned u substitution? I said that if you don't know u substitution, that you may as well pay the $15 and yeah. What's that? So, you know what I would do if I were you? One thing, a huge investment you could make over the next week and a half is take 2 or 3 hours out, go online, and just use substitution. Type in use substitution worksheet. Type in use substitution examples, use substitution problems, use substitution on the AP exam, whatever you want to type in. But use substitution needs to be a strength in your repertoire. That, and I have seen the product rule more than the quotient rule. But guess what I see more than the product rule? The chain rule. They love the chain rule. They really do.
There was a lot, I think, of that was use substitution on.
Yeah, there were at least 3, yeah.
Like I knew I was supposed to do it, I just couldn't remember how.
But now you know, right? Once you know what your weakness is, you can then, and it doesn't take, individual topics in AP Calculus can be strengthened in an hour. I mean, you can learn how to do almost anything in an hour as long as it's just one subject, one topic. Yeah, you had your hand up?
And differential equations was the other one.
Yeah, now, you wanna know something interesting? You can actually get away with not knowing differential equations and still get a 4 or a 5. Now, I'm not saying don't, but what I'm saying is they usually don't have more than maybe 2 or 3 differential equation problems on the whole test. So if you strategically decide what it is you're going to know and don't know, does that make sense? Okay? All right. But U substitution shows up in the middle of so many problems, it's one of those that you really have to know U substitution. All right, let's do number 3.
Oh, I got this.
Yay! All right. Remember we had that conversation right before we started? Okay, the limit as x approaches infinity of the square root of 9x to the 4th plus 1 over 4x squared plus 3.
They
Okay?
tried to trick us.
With the square root, right? Now, let me tell you something. With limits at infinity, because it's at infinity, we can always ignore the constants. We never have to worry about the constants. So this is really, the square root of 9x to the 4th is really just 3x squared, right? And now it's x squared over x squared, so it's 3 over 4. There we go. B. Did you do the square root of 4?
I did.
And choose
I did
3 over
9
2?
over 4. Like,
9 over 4, yeah.
I knew that it was going to be x to square, x
Right,
and x squared.
but then
I looked
yeah.
at just like the original coefficient, and I didn't.
Honest mistake. I mean, it's just one of those things, especially when you're under pressure, right? We make those kinds of mistakes sometimes. And unfortunately, the people who write the AP Calculus exam, they capitalize on the fact that, well, capitalize, they don't really gain. But I mean, you know, they make some of the answers. All right, so if we have y equals x over x plus 1 to the 5th power, we just want to know the derivative of this. So dy dx, okay, what rule are we going to use here? Yeah, and it's actually not just the chain rule. It's the chain rule and the quotient rule. Okay, so the chain rule, how do we do the chain rule? Step 1?
Derivative of the inside.
Okay, let's do that first. Let's ignore the 5th power and let's just do the derivative of the inside. Quotient rule, so how does that go?
U or x.
Yeah.
X squared.
Drew to the top,
1/2 x squared.
right? Right. Oh, but hang on. You're doing the antiderivative one. Yeah.
Just 1.
So 1 times
X plus 1.
the bottom, x plus 1, minus x times 1. There we go. This. Oh man. So this is really just x plus 1 minus x.
So it's 1.
It's 1. Okay, so the numerator is 1 over x plus 1 squared. Okay, so that's the derivative of the inside. Times, now, to do the derivative of the outside, pretend this is just an x. Just pretend this is an x. It's x to the 5th power. What's the derivative of x to the 5th power?
Where did 1 over x plus 1?
Okay,
Where did that come from?
so when we do the derivative of the inside, the quotient rule, derivative of the top, 1.
I got the 1 just where the bottom of that.
Oh, where did this? Because the last part of the quotient rule is over the bottom squared.
Oh, that's right.
Over the bottom squared, right? And so now, if this was just x to the 5th power, what would that be?
5x to the 4th.
5x to the 4th. But instead of 5x to the 4th, it's 5 something to the 4th.
X over x plus 1.
X over x plus 1. And now, unfortunately, they kind of required you to simplify. And let me show you something. Did you know that a fraction to a power on the outside, you can distribute that power to the numerator and the denominator? So this becomes x to the 4th now, and this becomes x plus 1 to the 4th. And now we have 1 times 5 times x to the 4th. Sorry, I know I'm going fast. I want to make sure that we cover as much as we can, but I don't want you to lose in the meantime. What's 1 times 5?
5.
And 5 times x to the 4th? 5x to the 4th. Over, look what we have here, x plus 1 squared times x plus 1 to the 4th.
X plus 1 is 6.
There you go. Which answer is that?
D.
D, there you go.
See, I got away with guessing.
Sure, you can do that too, right?
Get away with that.
Like you know that there's going to be a 5 in it, so it can't be B, right? Like you know that it's going to go down in power, so there's going to be a 4th in there somewhere. Well, that gives you all the rest of them. But you probably also know there's going to be a denominator, so it probably can't be A, unless maybe it cancels. So there's ways of figuring it out. All right. Should we try number 5? Okay. Oh, I'm not looking at my thing here. Number 5.
Right.
What?
Yeah, the most popular answer here was, the most popular wrong answer was D.
How about A?
Yeah.
No, I put D.
All right, let's try. I say most popular, only 4 people. Okay. Water is flowing into a tank at the rate R of T, where R is measured in gallons per minute and T is measured in minutes. The tank contains 15 gallons of water at time 0.
Oh, I forgot that.
Ah, there you go.
Yeah,
Wait,
that's
I
what.
did.
Yeah.
Values of R of T for selected values of T are given in the table above. Now, it says you want to approximate the number of gallons of water in the tank at time 9. If we had a calculator, and if we knew what the function was, how would we find how much water is in the tank?
Integral.
What would we start with?
From
0 to 9.
Okay, 0 to 9.
15.
We do 15 plus starting value plus the accumulated change of R of t, right? But all they're saying here is do this with a trapezoidal method. And so, how many trapezoids are we going to have?
4.
Well, there's
3.
4 numbers,
No,
3
Oh, I
spaces.
did a trapezoid.
4 numbers, 3 spaces. So we're going to have 3 trapezoids. What is the, okay, what are the heights on the first trapezoid?
9.
9 and 6. So 9 plus 6 over 2. And what is the width of that one?
4.
4. 0 to 4. Plus, what is the width of the second trapezoid? 3, because it goes from 4 to 7. And what are the heights of those two?
6.
6 and 4. So 6 plus 4 over 2. Now I want you to know, the way I do this without writing it down, I do this in my head sometimes. This is just the average height between 9 and 6. What's the average between 9 and 6? 7.5. 7.5 times 4 is, it's 30. Sorry, I was going to do 28. Sorry. It's 30, right? What's the average between 6 and 4? 5 times 3 is 15. And then the third trapezoid,
4 plus 3.
4 plus 3, because the heights are 4 and 3 over 2. And what is the width of that trapezoid? 2. Average between them is 3.5 times 2. So it's 15 plus 30 plus 15 plus 7. 67.
Dang it.
I will post the video. Go back and look at all this. All right. I do want to give you guys a chance to ask questions. Is there anything here you don't understand, or is it just... See, I find that the problem isn't that students don't understand it, it's that they don't remember to do it, right?
Exactly.
And that's just, you know, that's one of the things that I disagree with about exams, is that in real life, when I face a real problem,
Google.
I can Google it, I can call a friend, right, and say, hey man, I got this problem, can you help me solve it? Oh yeah, you know, let's go to McDonald's and have some
Should we take the
food.
exam together?
Yeah. That's exactly my point though, right? Is that exams, they seem to create this false world where we are all on our own. And unfortunately, there are lots of situations that promote that, like medical school. Oh, we can't help each other because if you do better than I do, then you'll get a better residence than I will.
Yeah, cousin went to
Right.
medical school, but you didn't go to medical school.
Yeah. I've heard there's so much competition in medical school. Well, that makes me nervous because I'm 45 years old and I would like for all the doctors to be cooperating with each other, please. You know what I mean?
Yeah.
Okay? When they all compete with each other, I lose. You know? Okay. So yeah, this whole exam thing, but you know, I get it. It's a rite of passage, you know, of sorts. All right, let's look at 6. Okay. The slope of the line tangent to the graph of the function, let's see, y equals natural log of 1 minus x. The slope of the line tangent to the graph of this at x equals -1 is. That is a very fancy way of asking a very simple question. You know what they're asking?
The slope.
What's the
Yeah. Yeah, what is the slope of the tangent line? The same thing as. What's our super special? Yeah, what's that?
Instantaneous.
The instantaneous rate of change, which is the slope, or the, starts with a D.
Derivative.
It's just the derivative.
Oh.
At x equals -1. That's what the slope of the tangent line is. All they're saying here is take the derivative and plug -1 in.
I mean, when you say it like that.
Well, right, but and see, that's the thing, is they want you to know all the meanings of what the derivative is. You know what I mean? So, what's that?
I plugged -1 in and then got the derivative.
Yeah, see, what you have to get the derivative first,
Okay.
then then plug -1.
What is it, C?
All right, is
I
it
just
C?
plugged -1
Oh.
in, and B was the only answer with a -2.
I guess.
Question 6. It's actually B.
I got it right.
I got
What?
it, but I don't think
Yeah.
I got there the right
All right, watch this. All right, What rule do we have to use here, TJ?
Which one is it?
The chain rule.
Chain rule, right? So what is the derivative of the inside?
-1.
-1. So that's the problem there, is that we have to start with -1 and then take the derivative of the outside, which is would be 1 over x, right? But instead of 1 over x, it's 1 over, well, hang on, remember the inside is unchanged. So it's 1 over 1 minus x.
Wait, can you do that again?
By the way, I met somebody, I tutor a student, and she told me that the way she was taught how to find the derivative of this, any log, any natural log, the way she was taught is it goes like this, that the derivative of the inside goes on the top, and then the inside goes on the bottom.
That's a good.
Yep, it is, isn't it? I was like, wow, I've never heard that before.
Derivative of
Yeah.
the outside over.
Yeah, if it's a natural log, the way you do it is you do the derivative of the inside over the inside. Okay? So if we just had the natural log of x, right? What's the derivative of x? 1, and what's on the inside? X. There we go.
Ooh.
So now, what's the derivative of the inside?
-1.
-1 over the inside. I'm going to teach it that way for the rest of my career.
So what's the answer?
I don't know if I'll ever teach AP Calc again.
Is it going to be 1/2 or -1/2?
-1/2. So now when we put -1 in, what's 1 minus -1? 2. So -1 over 2. -1/2.
Oh, I did not know that. Like,
But you got it,
I got it, but I did not get that right. Like, what is this?
like the procedure. Okay, so what if it was the natural log of x squared minus 5? Guys, what would the derivative of this be based on what we just said?
X,
Hang on.
2x
2x
over x squared minus 5.
over x squared minus 5.
That's a good trick.
It is a great trick, isn't it? That's how it goes from now on. That's how I teach it. That's the rule from now on. Derivative of the natural log is the derivative of the inside over the inside. Boom.
I'm gonna just
Yeah.
get rid of this.
Okay. Oh, that's fine too. All right. So should we try number 7?
Yes.
How you guys doing? You guys
I'm pretty sure I guessed
I
on
feel better
six.
now.
You guys okay? Good. Yeah.
Didn't have the correct reasoning.
Okay. I like this one. This relates to the conversation that we had right before we started, right?
Oh yeah.
Okay.
When you said infinite, I mean when you said the limit doesn't exist, that's infinite.
That means infinite. Yep. So what this is basically asking says, which of the following pairs of f and g will the limit as x approaches infinity of f over g be infinite? That means there's no limit.
Which means the numerator is greater than
The numerator has to be more powerful than the denominator, right? So all we're looking for, we got 5 options here, and we just want to pick one where the numerator is more, where f is more powerful than g.
C.
Is f in A, f is x squared, g is x squared. That's the same.
Will be 0.
Yeah, B, we got x cubed for f and x to the 4th for g,
0.
right? Yeah, g is stronger there. For C, which one is stronger? We got 3 to the x for f, and we got x to the 3rd.
Yes.
Yeah, remember what I said about exponential functions? At infinity, and this one is at infinity, exponentials are always the most powerful, right?
Yeah.
But at negative infinity, exponentials are always the least powerful. All right, so it's C. And if you look at D, they're equal power because they're both e to the x. E, they're both equal power because they're both natural log. All right, number 8. Okay, guess what you need to do this one?
Is that our
You need
quotient?
use substitution. Yep. And there are actually a couple ways of doing number 8. Do you want me to do both of them, or do you just want me to do one of them? Just one of them. Then I'll do the one that I think is the main way. So we have the definite integral from 0 to 4 of x over the square root of x squared plus 9 dx. Okay? So, because it's an integral, and because we have something complicated, do you notice this says x squared, and what is this? This is x to the first. So we have the derivative on the outside of what's on the inside. Perfect candidate for u substitution. Okay? So, u is going to be equal to x squared plus 9 du dx.
Would it be the
Yep.
square root of x?
No, that's the thing. We're gonna, when we put u in, we're gonna have the square root of u. And that's what we're gonna integrate, is the square root of u.
Oh, see, I just I put x plus 3.
I mean, you could, what was that? You put what?
X plus 3 instead of x squared plus 9.
That's because you thought this was factorable. Is that right? Oh, I see what you're saying. Because that's the problem, is that, remember the house of math? Radicals live on the third level. Addition lives on the first level. You can't get to addition from radicals. So it's more complicated than that.
So I'm not gonna try
Yeah.
that.
And I'm sure that they probably expected people to do something like that.
It didn't work.
All right, so du dx, the derivative of x squared plus 9 is 2x. So du is equal to 2x dx. Solve for dx. I'm going to do 1 over 2x on both sides. So I have 1 over 2x. Du is equal to dx. Yeah, I did times 1 over 2x on both sides. Cancel, cancel. Now, I'm going to replace this with u, and I'm going to replace this with 1 over 2x du. So we're going to have the definite integral. Well, let's just do the integral. We're not going to do the definite integral. We'll come back. Once we have an answer, we'll grab our 0 and our 4.
Okay.
So we're going to integrate x over the square root of u. We're replacing dx with 1 over 2x
Yeah.
du. Yeah. And now what's going to happen here, Jeremy?
The X is with cancel.
Yeah, because one's in the top and one's in the bottom. So really what we have is 1/2, 1 over the square root of u. Now, see this 1 over the square root of u? That's actually 1 over u to the 1/2 power, which is actually u to the negative 1/2 power. Right? Because we can change fractions. Denominators can gain a negative exponent and not be in a denominator anymore.
So would we need to simplify it that far?
In order to use the power rule of integration, yes. Because what do we now do? What is our power rule of integration?
Oh, power up.
Power up, add 1,
Reciprocal.
and then multiply by the reciprocal. So if we add 1, we get positive 1/2. And then what's the reciprocal of 1/2? 2. So we're going to multiply by 2, which is super convenient
Just 1.
because that's going to cancel out the 1/2 that we have in the front. So this is going to cancel.
Well, you're
Pow-
multiplying by 2.
Because remember,
Reciprocal.
right, because it's the reciprocal of 1/2.
Okay.
When we power up the negative 1/2, negative 1/2 plus 1 is 1/2. And then the reciprocal of that is 2, so that's what we're multiplying by.
Negative 1/2 plus 1 is 1/2.
Yes. Yep. It's like negative 0.5 plus 1. Right? So then what we have now is u to the 1/2 power plus c is our antiderivative. What is u to the 1/2 power?
That's u squared.
Other way around. Square root of. Remember, 1/2, that we just did it here, right? So this is basically just the square root of u. The square root of u. And since we're about to do a definite integral, we're about to plug stuff in, do we need the plus c? No, we don't need the plus c. You may want to go back and watch this part of the video. All right, now, what is u equal to? X squared plus 9. So all of this boils down to the square root of x squared plus 9, which we will then plug a 0 and a 4 into. Because it's a definite integral. I know. When I plug a 4 in, I get 16 plus 9.
5.
Yeah, I get square root of 25, which is 5. Minus, plug a 0 in,
3.
square root of 9, which is 3. And what's 5 minus 3? 2. There we go. Which is option 2.
Guessed -2 the first time, but then I did it wrong and I put the.
That'll happen too.
I should have guessed.
I recommend watching this video again and going back through this. Again, what was probably the most important skill in this problem? U substitution. Yep, U substitution. Necessary. There's probably a shortcut way of solving this, but
Who needs shortcuts? You got 55 minutes to
Wait,
make
can you go back and do the plug-in?
Yep.
part?
All right.
Out of the bracket?
Oh, if I say.
You understand why I
streak.
Yeah.
this is here, and because it's a definite integral, I got the 4 and the 1. When in a definite integral, we always plug the top number first, right? So if we have plug 4, and what's 4 squared? Plus 9. Square root of 25. There you go. Plug the 0 in. 0 squared. 0 plus 9.
9
Square root.
3.
There you go.
So it's the top minus the bottom.
Plug top in, then minus.
Okay.
Plug bottom in. Yep. Fundamental theorem of calculus, which we're going to see probably within the next 10 questions. We're going to see it again. Brandon.
Where did that 2 come from, like recap?
This one.
Yeah.
Right? Okay. So the antiderivative, remember that, okay, if we did the antiderivative of x to the 7th power, dx, we power up, right? And then multiply by the reciprocal of our new power. And when we powered up, we got 1/2. The reciprocal of 1/2 is 2, so we multiply by the reciprocal. Good. All right, let's go to 9. We're going to skip 11, by the way, because everybody got 11 right. But let's look at 9.
That's the one where you have to like.
Oh, nice.
Yeah, it was super easy.
I
I
really
want more
get
like
some.
that.
All right,
Yeah.
we got, okay, so 2 of you guys got number 9 correct. Okay,
Yeah.
Not me.
I did.
We'll see. All right, let F, maybe it was a first period thing. Let F be, well, because, you know, I have, right here, now that you're here, I have 3 periods represented. I have somebody from each class here. And isn't it possible that I went over one thing more in one class than I did in another class? So, all right, let's say let F be the function with derivative given by. So now they're giving us the derivative, which is negative 2x over the quantity of 1 plus x squared. Okay, squared. Okay. And it says, on what interval is F decreasing? We have the derivative. We want to know where the original function is decreasing.
Where was
We
negative?
we just want to know where the derivative is negative. And what tool can help us do that?
Oh, the second chart.
A sign chart. That's right, a secant chart. Right? See, it really caught on in first period. It didn't catch on in my other classes.
Being
The
that I
second
didn't
thing.
write anything for this,
Yeah.
I think I guessed.
Yeah. Oh,
I think,
are
I
you
think
sure?
my reasoning was. I think my reasoning was.
You can plug it in.
Like
That's what I did.
whenever like we draw like the derivative of like a function on there,
Yes.
it's always good, like the start's always going in a different direction.
Yeah.
So I did that.
I will tell you this.
See, I drew a sign
That-
chart. I just didn't put
I just thought about it,
anything in
like, if you put a negative in there, it's gonna be positive because the bottom's always positive.
Correct. Wait, that's actually really important. Okay, here's what she did, okay? Which is basically the way I did it. If you look at this denominator, we're concerned about zeros in denominators. But this denominator can't ever equal 0. Because it's squared, and the inside can't ever equal 0. Okay? Because this, no matter what we put in for here, this will either be 0 or positive. The lowest it can be is 0, and 1 plus 0 is 1. So the denominator is always positive. So the only thing that ever matters is the numerator. The numerator is going to decide whether the derivative is positive or negative. And what is the only thing that you can plug in there to get if you plug in a positive, then you will get a negative value no matter what. Right? So we know that there's a 0 at 0, and that whenever you plug in a negative number, you'll get a positive, and whenever you plug in a positive number, you'll get a negative. So it is a. See?
That is my
That's
one
it.
right
That's
question.
exactly how you do it. Right? All right, let's go on to 10. Oh, wait. I am so happy
Oh, I
11
did it
is the one you guys got right.
Put it on there, 'cause I did it outside.
You guys, do you guys remember
all 11.
do you remember the activity I gave you, the matching activity?
Yeah,
Yeah.
Oh yeah. Okay, let's go to 10. 10,
Yikes.
we got 50-50 again. We got 50-50 again on 10. All right, so we have the antiderivative, and I know why. We have the antiderivative of e to the x plus e dx. Now, I need to say something here before we start this. All we're doing is the antiderivative, a regular antiderivative. This isn't even a difficult antiderivative. Please don't hate me for saying that. I need to clarify. This e right here
Is
is a
number.
constant. It's not a variable.
So you just put.
So this is almost like doing, let's pretend it was e to the x plus 2,
Oh.
right? Well, what's the antiderivative of e to the x plus 2? E to the x plus 2x plus c, right? Only instead of a 2, we'll have an e. So it's e to the x plus ex plus c. E.
Yep.
See that? And I know that people look at e's sometimes and think of them as variables.
Yep.
Yeah.
But e is not a variable, it is a number.
I was like, E exists.
Okay,
out of
so-
X. Oh, God.
So I knew that the e to the x and the e could not be combined. I
Yes.
just forgot to do the anti-derivative.
Of the e?
Yeah.
Yeah, so
tried to
you
use-
you did e to the x plus e,
Yeah.
plus you picked c.
Yeah.
Yep, I can see that.
So which one?
It's
E.
it's e. Yep.
What you on 1, 2.
All right, just in case anybody's watching the video, everybody got 11 right. This one is f. Dun, dun, dun. What could f prime be? We've got negative, positive, negative. So we're looking for negative, positive, negative value. So negative value, positive value, negative value. There we go. And that's option B.
We get more like that.
I hope so. I do. I hope so.
Over those streets.
All right, 12.
I didn't know how to do this one.
All right.
Oh yeah.
Okay. All right. You may know better than you think.
I kind of finessed my way into A, but.
If C is a value between 0 and 1, so you got to think about that first. What is the area of the region enclosed by the graphs of y equals 0? Well, y equals 0 is basically just the x-axis, right? Okay. 1 over x. Now, you should, if this is the y-axis, I need you to know that 1 over x looks like this. You've probably seen 1 over x before. And x equals c and x equals 1. Well, x equals 1 is like right here. Is c on this side or this side?
That's
What?
it.
This side, right? Because it's between 0 and 1. So c is just some value right here. And we want the area of this. So how would you do that? Top minus bottom, what's the top? It's the function 1 over x, right? The bottom is 0, so I'd put minus 0. But I don't have to put minus 0. And what do I do to top minus bottom? I integrate from,
0 to.
well,
1 to C.
no,
0 to 1.
c to 1. No, right. Doesn't the region start with c? From c up to 1.
Okay,
dx.
cool.
Do you agree this is the area formula? And that we're going left bound to right bound? Top minus bottom? Alright, so what's the antiderivative of 1 over x?
Log of 1. Or
Natural log of
Square root. I mean,
opposite
absolute
value.
value.
x, right? Okay. Put that in the bracket. What do I put down here?
See?
A c, and up here,
It's 1.
a 1. What do I plug in first?
1.
1. So plug a 1 in and I get the natural log of 1
Minus.
minus
The natural log of C.
the natural log of c. And we don't need the absolute values because we know that both of these are positive numbers, right? Now, do you recall that there is a property of logarithms that, for example, if I have the natural log of x, if I have the natural log of x over y, did you know that's the same thing as the natural log of x minus the natural log of y? Subtraction between logs is division inside of logs if it's the same base.
So it's
1
so it's B.
Yeah, natural log of 1 over c. 1 divided by c, because this one's subtraction. Natural log of 1 over c. You guys, how many of you had Dr. Russell?
Yep.
Okay, Dr. Russell was tasked with teaching you everything about logarithms in a week. That is ridiculous. It doesn't make any sense that they would have. In the old days, you probably would have spent a couple months on logarithms in an honors algebra 2 class, and you would have dug deep. You would have done logarithms like crazy. You would be experts in logarithms by the time you get to AP Calc. But you guys were shafted. You guys, you got like a week of logarithms, if that. Okay, so I'm sorry about that. You may want to go back and just type in the internet properties of logarithms. About 15 minutes worth of reading might be enough for you to know all this, the basics of logarithms. Okay. Okay. Let's do 13.
How fast are we moving?
Okay, we're doing pretty good here. All right, 13.
Ooh, I got that one right.
You did. All right. Let me explain the problem with 13 is that I didn't teach you the derivative of tan inverse. All right, so I'm going to teach you it right now.
Oh, that was that thing that you told in the morning, right?
Yep.
Yeah.
Yeah. All right, so the derivative of tan inverse is 1 over 1 plus x squared. And if you didn't know that, there's no way you could have answered this question. Of course, you probably could have skipped the question, but that's the derivative of tan inverse. You just kind of have to memorize it.
You told me that, that's why this is saying.
Well, I told you like one time, right? So that doesn't
So
really
do
count.
the deer.
I hate when that happens.
So I think.
All right, so if we know that, then this question is asking us what is the derivative of tan inverse of x plus 2 square root of x. That now makes this the hardest part of the derivative. Do we need the product rule here? No. Do we need the quotient rule or the chain rule? No, it's just it's really just the power rule for this and then whatever the rule is for tan inverse.
It's just easy.
It is easy. So the derivative of this is 1 over 1 plus x
Hey,
squared.
I got it wrong too.
Yeah.
Oh.
Yeah, but did you know the derivative of tan inverse? See, that's, so you can't really be faulted for that. But now we have this review session, and you now can know what the derivative of tan inverse is. All right, now this is probably the hard part. That's the same thing as 2x to the 1/2 power, which we can now apply the power rule to. 1/2 times 2 is 1. X to the, what do we have to do to this? In a derivative, we subtract, right? Subtract for derivative,
So,
add for
negative
integral.
1/2.
So negative 1/2, and what is x to the negative 1/2? 1 over x to the 1/2,
So 1 over the square root of x.
1 over the square root of x. So
Wait,
it's,
I thought you can't have radicals in the numerator,
That's a lie.
denominator.
no, right, okay, that is a lie that algebra teachers told you because that's what they were told. It's a long line of algebra people
Dr. Russell.
making, well, okay, in all fairness, he would be held responsible to other algebra teachers if he didn't teach you to rationalize the denominator. Okay, but once you get to calculus class, we don't care about rationalizing the denominator, and we're okay with radicals in the denominator.
But school is just a compilation of lies.
Well, it is. It actually is. And that's learning, which is why it's important to understand that your learning belongs to you. To you. There are teachers out there that say that y equals the square root of x, that the graph of y equals the square root of x looks like this. And I say that the graph of y equals the square root of x looks like this because it's the inverse of x squared. And they say, yeah, but now it's not a function. And I say, no, you put that requirement on it. You said it had to be a function. I don't think it has to be a function. In fact, it's not a function. They say, well, if you want it to look like this, you have to put a plus or minus in front of it. No, the fact that it's a square root of x implies that it's plus or minus. But then I get in trouble. I'm not kidding you. If it was me against 1,000 math teachers, it would be 1,000 math teachers standing over there and me standing over here making this claim. And it would look like I was wrong because it's 1,000 versus 1. But I'm not wrong, and they're not wrong either. It really just depends on how you decide to communicate it. They want to communicate it as a function that passes the vertical line test. Which makes sense, because if you want to apply function properties to it, then you need it to pass the vertical line test. But I say nay, nay. Have you guys seen that comedian before? He's got this whole bit where I say nay, nay. Okay.
Can you do the 2x 1/2 like a derivative thing again?
This right here, right?
Yeah.
Okay. You agree that 3x to the 4th power has a derivative where you multiply this and this first, right?
Yeah.
And then you reduce this by 1, right? So that's how we find a derivative. So what I'm doing here is I'm multiplying this and this,
Okay.
which gives me 1. I'm keeping the x, and then I'm going to subtract 1 from 1/2,
So
right?
it'd be -1.
Negative 1/2, that's right. Yep.
Hide my shame.
So yeah, it's a whole bunch of lies, but here's the thing is, they're not really lies. They're just different ways of communicating the same thing. You get out there, and when you're learning in college, don't think that your professor is the master of knowledge that's telling you what's right. All your professor is a resource to help you understand better. Because when you leave college, you will be the master. Yeah, when I left you, I was but a learner. Now I am the master. There's got to be a Star Wars quote for every situation.
Yeah.
Oh, so did we pick
Many bottoms died.
E?
We did.
We did now.
Okay. All right. 14. Then I'm gonna break the video and do a new one because I have to do 1 hour chunks.
Okay.
All right. 14. Why f of x is a solution? Oh yeah.
This one had my head going.
We did not have to act. Okay. Let's just talk about this one. By the way, guys, I believe this is probably one of the top 3 most difficult questions in multiple choice. I actually started solving this and then I had to walk away and go do something else and then come back to it with a fresh mind. If that happens to you, move on to 15 and come back to it. Okay? You need your brain to rest. Here's what it says. It says, if y equals f of x is a solution to the differential equation dy dx equals e to the x squared and has initial condition f of 0 equals 2, which of the following is true? And then it gives you A, B, C, D, and E. Yeah.
For a way to figure this out, since I didn't write anything, but I got it right.
Uh-huh.
We'll see.
It said the initial. It's C
It's
D.
D.
Oh, that's
So it says the condition is f of 0 equals 2. That gives you an x value. And
Yes.
I looked at D, and the bottom one was 0.
Yes.
Is that good
Right.
enough reasoning to like put that for all of them?
Yes. Let's use that reasoning, and we're going to use that, and so that people on the video can follow along if they need to. Here's what we're going to do. We're going to plug 0, 2 into every answer, and knock out a couple of them if we can. If we plug 0 in for x, okay, in option A, we would get e to the 0 power, which is 1, right? And 1 plus 1 is 2, so A is good, right? Does that make sense?
Yeah.
Okay. If we plug,
0.
hang on a second, I need to, yeah, if we plug 0 in for B,
Nope.
the answer would be 0. So we know B is incorrect because we'd have 2 times 0 times anything is going to be 0. So we know it can't be B. Let's plug it in for C. If we put 0 in there, okay, e to the x squared, where is that function graphically? Or where is that graph?
There's an increasing.
Yeah, it's above the x-axis. E has always positive values. Squaring it is just going to make it steeper, that's all. Okay, I mean squaring it, doing e to the x squared is just going to make it go steeper faster. So would you agree that any integral from the left to the right will be a positive number, and any integral from the right to the left will be a negative number, right? So if you look at option C, if we integrate from 1 back to 0, it's going to be negative. So C can't be correct
Right.
because we need a 2, right? Okay. Option D, so it can't be B, it can't be C. Option D. If we plug 0 in for x, we have an integral, we have 2 plus a definite integral from 0 to 0. Well, what is the definite integral from 0 to 0 going to be?
0.
It's going to be 0, right? Okay. Plus 2 is 2, so D is a possibility. So right now we're at A and D are possible. How about E? If we plug 0 in for that x, we're going to integrate from 2 backwards to 0. So that's going to be what kind of a number? A negative number. And then we're going to add 2 to it. If we add 2 and a negative number, will that equal 2?
No.
Nope, can't be e.
Okay.
See the logic here? So now we're at, is it A or is it D? Well, let's write D and A up on the board. A says that f of x is equal to 1 plus e to the x squared. And D says f of x is equal to 2 plus the definite integral from 0 to x e to the t squared dt. Well, if this is y, the derivative is e to the x squared. Well, what's the derivative of this? Think about it.
E to the x.
No, hang on.
E to the 2x.
No, yeah, what's step
E
1?
to the 2x.
No, hang on. No, we don't
chain
do
rule 2x.
chain
Oh,
rule.
it's a chain rule.
2x
Times
E
e
to
to
the
the
x
x squared.
to the x squared.
Okay.
That's not it.
That's not it. So, just to be fair, let's make sure we do the derivative here. Derivative of 2, 0, right? Fundamental theorem of calculus. What's the derivative here? Plug x in for t and multiply by the derivative of this.
Oh, yeah.
Derivative of this is 1 times e to the x squared.
So it's just e to x squared.
There you go.
So what if like I narrowed it down because the last two add 2?
Mhm.
Is that like okay or is it?
Yeah, that's great. Yeah. So, but did you then figure out that e is wrong because if you integrate from 2 to 0, you'd have a negative number? There you go. And I think that's what they expected students to do, not actually solve the differential equation.
Yeah.
Okay.
I tried.
I tried it, it didn't work.
Yeah, I tried it too.
So then that's what I did.
I had a lot of fun, and I was like, yeah, this isn't working. That's why I walked away, and then I came back, and then I was like, oh, wait a minute here. Fundamental theorem of calculus. I need to find the one that has the derivative, e to the x squared. There we go. All right. All right, let me go, let's take a break for a couple minutes while I go restart the video. We'll pick back up on 15. How are you guys hanging? You guys hanging in there okay?
Oh, yeah.
All right. Learning a little bit?
Oh, a lot.
Yes.
Good, good.
100%
Right.
right.
Seth? This was in my box for you. Congratulations.
My God. When's this?